Assalamualaikum and hi guys. So today we are going to continue our lesson on chemical bonding 4.1 Lewis structure. Okay, so at the end of this lesson, you should be able to draw Lewis structure of covalent species with single, double, and triple bonds. So there are actually 4 simple steps to draw the correct Lewis structure. The first step is TeV, which stands for total valence electrons. So the very first step, you need to calculate or count the total number of valence electrons for all atoms in the covalent molecule. But for polyatomic ions, as they gain or lose electron to form the ion, okay, so we need to consider the number of electrons here. So we need to add 1 electron for each negative charge of the ions. This corresponds to the anion. So when we have an ion, we need to add electron. Depends on the charge of the anion. Let's say for example we have CO3 2 minus, so that means we need to add 2 electrons. While when we are forming cation, that means we remove electrons. So we need to subtract 1 electron from each positive charge. Right? Next, the second step is known as S, which corresponds to the skeletal structure. So after you have count the total number of valence electrons, you need to draw the skeletal structure. The function of the skeletal structure is to show how atoms are bonded to each other. First thing first, you need to decide who's going to be the central and who's going to be the terminal atom. So central atom means that atom at the central. Okay. More electropositive atom tend to be at the center, while more electronegative atom tend to be at the terminal. So how are we going to determine electropositivity and electronegativity of elements? So back to the lesson that we've learned in chapter 3. Across the period, how is the electronegativity trend? Can you recall? Across the period, atomic radius decreases, so electronegativity increases. Down the group, atomic radius increases, so electronegativity decreases. Right? So that's mean if we have 2 elements, you need to look at the position of the element in the periodic table. Let's say we have element from group 14 and element from group 16. So the element at group 16, of course, is more electronegative. So it's going to be the terminal atom, while the electron at the more far left side of the periodic table should be the central atom because it is more electropositive. But since hydrogen can only form 1 bond, so hydrogen is always a terminal atom. Right? Remember that it can never be a central atom. So hydrogen, it can always be a terminal atom because it can only form 1 bond. So how are we going to draw the skeletal structure? After deciding who's going to be the central and terminal atom, we need to draw a single bond between central and terminal atom. You should know by now that each line or bond means that 2 electrons has been used. So now we have to subtract the total number of electrons used, subtract the number of electrons used to make the bond from the total valence electron in step 2. Next, step 3 is O. O means we need to octet to make sure that the terminal atom is already octet. Octet means it has 8 valence electrons surrounding the terminal atom. And if your terminal atom is made up of hydrogen, so that means we have to ensure that the hydrogen already has achieved the duplet configuration. Next, the final step is C. What's meant by C? C means check. What do we have to check? So the first thing you need to check is whether are there any remaining valence electrons. If there are, yes, if there is any, then you have to put the valence on the central atom. Okay, C means you have to check if there are remaining VE, put it on the central atom. But if there are no remaining valence electrons, so what are we going to do? Right? So if there are no remaining valence electron, you need to check whether the central is octet or not. If yes, then let it be. That means you have already achieved octet or stable configuration for both the terminal and also the central atom. But when the central atom is not octet and you have no remaining valence electron, so you have to make it octet. How? Okay, it says that if a central atom does not have an octet, so we have to make multiple bonds by changing a lone pair from one of the terminal atoms into bonding pair to the central atom. So use lone pair from terminal atom to form multiple so let's figure out all the steps in the example. So as we can see, the 4 steps to draw the Lewis structure is the acronym is read as TVSOC. So by now you should know that there are 4 steps, okay, to draw the correct Lewis structure, which is known as TVSOC. So now let's practice. If you were given, for example, we have PCl3. So the very first step you need to do is TV, calculate the total valence electron. Right? So phosphorus is the element in group 15. So it consists of 5 valence electrons. Next, we have chlorine. Chlorine is the element in group 17. It has 7 valence electrons. Since in 1 mole of PCl3, there are 3 mole of chlorine atoms, so we need to times by 3. So the total valence electron for PCl3 is 26. Right. If you can't remember what is the valence electron for the element listed in the compound, what should you do? Yes, you should refer to the table given, take its proton number, which is equal to its number of electrons, and then you have to do the electronic configuration in SPDF notation in order to determine its valence electron. Right? It's quite lengthy, but it's worth it. So the second step is S. S means skeletal. Okay, I write down again total valence. as skeleton. So in order to draw the skeletal structure, we need to decide whether P or Cl is going to be the central atom. So if we look here, phosphorus is from group 15. So it is located in the far left of the periodic table compared to the chlorine. So phosphorus is more electropositive. Therefore, who's going to be the central atom? Yes, it's going to be phosphorus is going to be the central atom. Next, when we draw the skeleton, we need to draw the bonds connecting central to the terminal atom. Right? Next, we move on to the step 3. Step 3 is O. O means octet. Octet. Okay, so we need to ensure that the terminal atoms is octet. So now each chlorine atom has already gained 2 electrons from the bonding with the central atom P. So that's means in order to achieve octet configuration, it still needs 6 valence electrons. So we make it become octet by putting 3 lone pair on each chlorine. Right? So now, okay, all chlorine is octet. That means there are 8 valence electrons surrounding each of the chlorine atom, which is the terminal atom. Right, next we move on to the final step, which is C. C means you have to check, right? So in order to check, we need check whether there are any valence electron or not. We need to count the number of valence electron we use. So we have here 8 and 8 valence electrons. So altogether we have used 24 valence electrons. So we still have 2 valence electrons remaining. So where are we going to put these 2 remaining electrons? Yes, we need to put it on the central atom. Good. So now the phosphorus has how many electrons surrounded it? 2, 4, 6, 8. So now the central atom, which is the phosphorus, is also stable and achieve the octet configuration. Right. So next, we try on another example which involve the polyatomic ions. So for example, I have carbonate ion, CO3 2 minus ions. Now we repeat the same step, okay, in which the first step is TV. So we need to calculate the total valence electron in the polyatomic ions. Okay, since carbon is in group 14, so carbon consists of 4 valence electron, while oxygen consists of 6 valence electron. Since in one mole of carbon in 1 mole of carbonate ions, there are 3 mole of oxygen atoms, so we need to times by 3. Right? So there are 22 valence electron. But we need to pay particular attention on the charge. Right? So if you can see here, the charge is 2 minus. That means the chlorine ion gain 2 mole of electrons. So we need to add another 2 electrons, becoming 24 valence electron. So next, we move on to the next step, which is S. S means draw the skeleton, right? So between carbon and oxygen, carbon is in group 14, while oxygen is in group 16. So carbon is located on the far left, far left of the periodic table compared to the oxygen. So carbon is going to be the central atom.